Okay, guys, again, I forgot my thingy-majigger that props us up at work again. So it's still at the school. But today we're going to take notes on domain and range. That looks like a 2, and it's actually a 1. This is going to be part 1 of 3. We're going to chunk this note section up because it's pretty heavy. Lots of information is covered, and I just want to make sure that we do a good job and we actually understand what we're doing. So before we get started, we actually got to talk about what domain and range are. So domain is all, it should be familiar. Domain is all possible input values. Of a function. Typically, domain refers to the x value. So I'm just going to put x there. So that way you know we're talking about variables x. So we're talking about all the possible x values. That's the way I like to think of it, at least. And then we have the range, which is all possible output values. Of a function. Again, think of this as the y values. Okay, so domain is x, range is y. Sorry, it keeps blurring in and out. So dang iPhone is too fancy for us. All right, so then now we're going to talk about open and close because we're going to specifically focus on graphs today. And so some things to note about notation is that we have different things, different symbols that recognize whether an interval is opened or closed. And so the first thing that we have to denote whether an interval is open or closed, sorry, I had to take the cap off the pen, open or closed, is if an interval is open on a graph, then typically we're going to look at an open circle, right? If there's an open circle, then that means it's opened. Vice versa, if it's closed on a graph, then that circle is closed. So open, closed. All right, this should be familiar. Next, if a function is open, we usually would write the inequality that represents the domain as an inequality symbol that looks like that. So the alligator that has no teeth, all right? And vice versa, if it's closed, then the inequality symbol is going to have a line underneath it because it could be equal. Remember, that's the whole point of the point on a graph, is that if it's closed, then that means it actually does equal that value there. And then finally, what we're going to be talking about today is interval notation, which is my favorite, which you would have learned in Integrated 2 and maybe in Integrated 3. If not, we're going to cover it again. In interval notation, if a interval is open, then we denote the interval with parentheses. And then if the interval is closed, we denote it with brackets. So this is just the different ways that we can represent an open interval versus a closed interval. Okay, so now that brings us to using proper notation. So here I'm giving a bunch of inequalities, and we're going to write it in interval notation, and we're going to also write it in set notation. And now interval notation, well, let's talk about inequality notation. The inequality is how you're first taught to look at it. So this is the basic version. If we write something in inequality notation, this is just pretty basic. It's understood since 7th grade, really, what an inequality means, okay? The interval notation, which is what we're going to be practicing, the interval is going to be the useful one. This is, as you get farther into mathematics, it's going to be easier to just use interval notation because it uses less symbols. And then finally, set notation is formal. So when you get into your upper level maths, you're going to be using set notation to describe your proofs and describe your set of data, okay? So let's get started. We're just going to take all of these inequalities and we're going to rewrite them in interval notation, and then we're going to focus on rewriting them in formal notation. So interval notation, the reason why I like it is you just look at the numbers that you're given at face value. So I'm given 0 and I'm given 10. Okay, so 0 to 10. And what this inequality reads is that 0 is less than h, which is less than or equal to 10. And what I'm going to do is pay attention to those inequality symbols. So notice that there's an open inequality there. There's no line underneath it. And then there's a closed inequality there. So if there's an open inequality, I'm going to use a parenthesis. And then a closed inequality, it's going to be a bracket. And this notation right here means the same thing as this. 0 is less than h, which is less than or equal to 10. Or 0, h is between 0 and 10, with it possibly equaling 10. We're going to do the same thing with the next one. The beginning and the end, 5 and 10. And then again, pay attention to those inequalities. I have an inequality that is closed. So then here, I'm going to have 2 brackets to represent that the interval is closed from 5 to 10. This just means that it could equal 5 or 10 or any number in between. All right, let's look at the next one. We got 5 to 10 again. And this time, I don't have any closed intervals. I only have open intervals, which just means I'm going to put parentheses around it. There you go. Next one reads a little bit differently. It says h can be anything less than 10. So anything less than 10 here, because we have to have 2 numbers, that means we could actually go all the way to negative infinity, because negative infinity is the lowest number we can go to that's less than 10. Now, infinity always has a parenthesis around it. And the reason why infinity always has a parenthesis around it is because infinity is an idea. It's not an actual number. So we can't actually equal it. And then when I look here at my inequality, I also have an open interval. So I'm going to just put a parenthesis around the 10. So here, h is between negative infinity and 10. Next one, vice versa. H is bigger than or equal to 10. That means my possible values are from 10 to infinity. And actually, let's be specific, positive infinity. And then here, it can equal 10. That's what that inequality means. It means it's either 10 or it's bigger than 10. And then again, infinity always has a parenthesis. You will get marked down if you put a bracket around infinity, so please don't do that. Finally, we have from negative infinity to infinity. Negative infinity to infinity, we just write the numbers. Negative infinity to infinity. And this one is going to be enclosed in parentheses because negative infinity and positive infinity are not actual numbers, they're ideas. So it's just the idea that it could be any number you could think of. All right. Now set notation is more formal. Set notation takes your variable that you're talking about. So here we're talking about h. And you always start with h. And then you write this line, which means such that. So you guys saw me abbreviating ST. In set notation, this line means such that. And we're actually going to put it in these fancy squiggly brackets. So how we write this is h such that, and then to complete the the set notation, I am going to copy and paste my inequality. So h such that 0 is less than h is less than or equal to 10. And then I complete it with the fancy bracket. All right, so that is set notation. Again, it just has the variable that we're talking about on the outside, the line, copy and paste the inequality. So let's do this one again. H such that, and then we're gonna copy and paste the 5 is less than or equal to h is less than or equal to 10. And enclose it with the fancy bracket. So here it's really writing a sentence in math for you. So instead of 5 is less than or equal to h is less than or equal to 10, it's saying a variable h such that the value is between 5 and 10. Okay. And continue. H such that, and then again, copy, paste, 5 is less than h, 5 is less than 10. complete with the squiggly bracket. It really bothers me that it gets so blurry. H such that H is bigger than or equal to 10. Ooh, I should have kept it in purple. Ah, that's gonna bother all of us. Gonna go over in purple, which isn't great. Squiggly bracket, you notice as we go down, my brackets are getting less fancy. All right, we'll try to do a good job with this bracket. H such that this time we have H's, oops, I even flip-flopped them, didn't I? So since I flip-flopped them, let's go over here. And then of course, be sure to make a note that this has been flip-flopped. All right, just read a little too far ahead. Finally, the notation for this one's different, so don't touch it yet. The notation for this one is it's from negative infinity to infinity. Then formal notation is actually just a symbol for all real numbers, because really what we're talking about is all real numbers, which is that fancy looking double R. Okay. All right, so now we're going to talk about domain range. Now, when we're talking about domain, we're talking about all the possible X values. So here, let's make it so my camera is not zooming out on its own. So remember, domain is all the possible X values, and we're going to write it in all of the possible notations, starting with what I like to start with is interval notation. So for domain, we look at the X values. Well, this graph runs from the year 2000 to 2050. So the domain is anywhere between 2000 and 2050. So when I go ahead and I write that in set notation, sorry, interval notation, we're going to write 2000 to 2050. And these are both closed circles, which means that in interval notation, I'm going to have brackets from 2000 to 2050. Okay. Now here, remember in the domain, you're talking about the variable X. So I'm going to rewrite this in inequality notation. Wrote it interval notation. Now I'm writing it in inequality notation. So domain is X. So it's really important that when you write your inequality, you include the variable X. H was just a placeholder, so we could talk about all variables. But here I do have to use X because I'm talking about the X-axis for my domain. Okay, so 2000 is less than or equal to X is less than or equal to 50. And again, this closed interval is going to be represented by the inequality with a line underneath it. And then finally, for the domain in set notation, do that fancy squiggly line. And this time we're going to choose the variable X because again, we're talking about the domain. So X such that 2000 is less than or equal to X is less than or equal to 2050. All right, so that's going to complete the domain for this function. Now we need to talk about the range. And the range is different. The range is looking at all the possible Y values. So look, this function goes from 0 on the Y-axis to 750 on the Y-axis. That's the highest point. So the lowest point is 0, highest point is 750. And both of them are closed circles. So that means when I write the range, I'm going to write the interval from 0 to 750. That is the range. And again, it's closed because I have two closed circles at the beginning and at the end. Doesn't really matter what's going on in between. Beginning and end is closed. All right. Next, I am going to write my range in inequality notation. So here I need to account for the variable. When we're talking about range, we're talking about the variable y. So 0 is less than or equal to y is less than or equal to 750. Okay. And then finally, the set notation, y such that, make sure you enclose it in the squiggly line, 0 is less than or equal to y is less than or equal to 750. Look at that, you did your first problem, okay? This next one is going to be our last problem for today, and it's a little bit different. This time we do include the open circle, so that is going to affect both our domain and our range. So let's think about that. If we're having our interval, we're talking about the domain, we're talking about the possible x values. Well, it looks like this graph starts at x equal to 0, but then it goes all the way off into infinity. So let's go ahead and write 0 to infinity, because we know that's the beginning and that's the end. Now, this again is talking about interval notation, so am I going to use a bracket or parenthesis? Well, this is an open circle, so 0 is going to be enclosed in a parenthesis, and then infinity is always closed in a parenthesis. So that is my interval notation. Next, we're going to work towards the inequality notation. Inequality notation, we can even shorten it. So instead of saying 0 to x to infinity, what I'm going to do is I'm going to say that, actually we do have to enclose it from 0, sorry. we're going to say x is bigger than 0. And the reason why I do that is because x is just bigger than 0. And I could write 0 is between, x is between 0 and infinity, but writing x is bigger than 0 is just going to save me some handwriting right now. All right. And then finally, to write it in set notation, the fancy squiggly, x such that x is bigger than 0. And actually, it's going to bother me that these don't have lines through them. All right, so that's my domain. We're going to do the same thing with y, the range. Now, on the range, the lowest possible value is at -1. So here we do care about where it is on the y-axis. We did before too. So here, lowest point is at -1. And what we're going to do now is we're going to go from -1. And this one actually seems to cap out at 2. It doesn't ever go above 2. So it's going to cap out at 2. So it goes from -1 to 2. And it looks like it might actually reach 2 at some point. And so, because it looks like all of these lines are at 2, but it also could be that they're getting infinitesimally close. So because they're becoming infinitesimally close to 2, we're going to put a parenthesis around it. So it looks like it reaches it, but it actually doesn't. So it goes from -1 to 2. Next, we got to write it in inequality notation. In this one, because I do have a beginning and I do have an end, I am going to sandwich the variable y between -1 and 2. Okay? And then finally, set notation. Write that fancy bracket, y such that -1 is less than y is less than 2. And you mathed. Right, that's going to be it for our notes today. Pretty easy, but I guess that just means tomorrow is going to be hard.